Hello everyone and welcome back. My name is Mr. Kovalt, and in this video we're going to be using bond energies and the idea of how the bond energies are linked to the enthalpy of a reaction in order to find the bond energy of a certain molecule. So let's get into this. So in this problem we're asked to consider the reaction A2 plus B2 gives us 2AB, and the heat of the reaction is a negative 285 kilojoules. And they tell us that the bond energy of B2 is 432 kilojoules per mole. They also tell us that the bond energy for AB is twice the amount of the bond energy of A2. And then they were asking us determine the A2 bond energy. Okay, so the first thing we want to know is we need to associate or link up the bond energies with the enthalpy of a reaction. So the enthalpy of the reaction, it can be estimated by the bonds broken and the bonds formed. When you break a bond, you're going to have to put energy in. So it requires energy to break a bond. So anytime you're breaking bonds, that's going to be endothermic, meaning energy has to be absorbed or put into the system. And then when you're forming bonds, that's going to release energy, right? Because you're going from high potential energy to lower potential energy. So energy is released when you form bonds. That's going to be exothermic, and that's going to be negative. So in order to put that together in an equation, the way you want to write it is that delta H, right, of a reaction is going to be equal to, well, we want to break bonds, so we're going to put energy in. So you're going to look up the bond energies. The thing that I realize is that all the bond energies you look up are going to be positive. So they're written as a positive number. So that's the energy that you need to add in order to break a bond. So this is going to be the sum of the bonds broken, right? And this is going to be the reactants. So you break all the bonds of the reactants and you add them together. That's what the sum sign means. And then you're going to reform new bonds, right? So when you form bonds, that's going to release energy. And so when you look up the bond energies of the bonds you're going to be putting together, they're going to be positive. But remember, this is going to be a release of energy, an exothermic process. So we need a negative sign here. We're going to subtract, and then it's going to be the sign or the sum of the bonds formed. And that's going to be the products. Okay? So that's the equation that we would use. Now, here we're just given generic A2 and B2 and AB, so we don't know what the bonds are, so we can't really look up in a table, but we can still use this to write out the equation. So let's write out the other things we're given. So we know that B2, right, that's got two bonds or two B's bonded together. We don't know what the bond is, a single bond, double bond, but we do have the bond energy. So for the bond energy for B2, that's going to be equal to 432 kilojoules per mole. Okay. And what else are we given? We're given that the bond energy of AB is twice that of A2. So we can write that as an equation. So AB, the bond energy of AB is going to be equal to twice the bond energy of A2. So that's going to be equal to 2 times A2. Okay, so now that we have that written out, we can then kind of write out this equation. So this equation, if we put it together, the delta H of the reaction is going to be equal to, if I put it simply, it's going to be reactants minus products. So the reactants are A2 and B2, so it's going to be A2 plus B2 minus the sum of the products. So if we put this in parentheses, right, so this is our reactants, and we're going to subtract that of the products. We only have one product, and so it's going to be AB, or in this case, 2AB, because it's the molar amount or the number of bonds we have to break. So since I have 2AB there, then I need to break 2 of those, so there's a 2 there. For each of these, there's only 1, so I don't really need to write the 1s in, right? But if this was a 2 coefficient, then I would have a 2 there for the A2, because I would have to break 2 of these, and that requires energy. Okay, so now I should probably, yeah, so that should be fine. You might say the molar amount, so N, you can multiply that by N, whatever the number moles is. So you might put that in there as well. But that's kind of taken into consideration when you're counting all the bonds formed that you're forming. So that's probably not necessary. Okay, but we're adding it here. So this is the number of bonds. I have 2 ABs, so whatever the bond is between AB, I have to form 2 of those. Okay, so here's my equation. So now I plug in the information that I have here. So I know B2, the bond for the energy for breaking the B2 bond is going to be 432. So, and I have the delta H of the reaction, so I can plug that in. So let's go ahead and plug that in. So it's a negative 285 kilojoules. Okay. And so then this here is going to be equal to, well, I have A squared plus B squared. So A2 plus B2. A2, we're going to have to find. B2 we're given is 432. So that's going to be A2 plus 432 kilojoules per mole. All of this is kilojoules per mole. And then we can put kilojoules per mole here just to be clear. Kilojoules per mole. And now this is minus, and notice I have 2AB here, right? But I know AB is equal to 2A2. So I can replace AB with 2A2. So that's going to be 2 times 2A2. So I took this and replaced it with this. So that goes there, and now I have that there. So now I can simplify it. So this is going to be minus 285 kilojoules per mole equal to A2 plus 432 kilojoules per mole minus 2 times 2 is 4, so 4A2. Now I can add this A2 and this A2, so this is going to be negative 285 kilojoules per mole, and then A2 minus 4A2 is going to be a minus 3A2 plus 432 kilojoules per mole. And now I can subtract 432 from both sides. So I'm going to do that. So minus 432 kilojoules per mole minus 432 kilojoules per mole. So that cancels out. Now I add these two together, and I'm going to go ahead and continue up here. So when I add those, I get 717 kilojoules per mole, and that's equal to minus 3A 2. And now I can divide both sides by minus 3. The minus and my minus cancel each other out, give me a plus. That cancels. And now I have A2 is equal to, let me look it up, 239 kilojoules per mole. And that, ladies and gentlemen, is how you get the answer. That's how you solve this problem. I hope this was helpful. If you enjoyed the video, if this helped you in any way, then please, by all means, like the video, share the video, hit that like button somewhere over there. Also, do me a favor, subscribe to my channel. Hit that notification bell. When you do, make sure you click all so you can be notified by all the videos I put out. Finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a problem, or if you need help with a question, let me know. If you have a topic you want me to cover, let me know that too. Just write it down below in the comment section. Okay, that's it. Thanks for joining me, and have a great day.